Welcome to our channel once again. Here we will see part 3 of HCF and LCM. This is the final part of this chapter. We will see some questions which are generally asked in placement campus life. And the first question is, find the greatest number which on dividing 1657 and 2037 leaves remainder 6 and 5 respectively. So how to approach this types of questions? See, whenever in this type of question, whenever question asks for greatest number, always remember that you need to find HCF here. That's all. So, but you will not find HCF of 1657 and 2037 directly because the question says the greatest number on dividing this and this gives remainder this and this respectively. Okay? So, how to solve it? First, we will subtract the number with its corresponding remainder. First we will subtract, let us suppose N1, the first number, 1657 minus its corresponding remainder, which is 6. The result will be 1651. Now, similarly, N2, which is equals to 2037 minus its corresponding remainder, which is 5. 2032 will be the answer. After getting result from subtraction, then find HCF. Now we will find the HCF of N1 which is 1651 and N2 which is 2032. Okay. So what will be the HCF of 1651? This will be 127. Okay. So 127 is prime. So this number cannot be divided by any number except 127 itself. So the HCF of, so we can write 1651 as 13 into 127. Similarly for 2032. 2032. 0, 1, 5, 0, 8, 4, 5, 4, 2. Okay. So 2032 can be written as 2 into 2 into 2 into 2 into 127. Now, what are the common elements in this 2? Only 127. Okay. So we can see 127 is present here also and here also. So 127 is the only common element. So we can write HCF of 1651 and 2032 is 70. Sorry, 127. So this is the required greatest number which on dividing 1657 and 2037 leaves remainder 6 and 5 respectively. Okay, now we will see the next type of question. The question says find the least number which on dividing 20, 25, 35 and 40 leaves remainder 14, 19, 21 and 34 respectively. In this question we have to find least number. So whenever questions ask to find least number, always try to find LCM. That's all. So see, whatever be the least number, when that least number divides 20, leaves remainder 14. When that same least number divides 25, leaves remainder 19. Similarly for 35, leaves remainder 21 and for 40, leaves remainder 34. So how to approach this type of questions? To solve these types of questions, simply find the LCM of the given number. Okay. So first we will find the LCM of 20, 25, 35 and 40. Okay. 5, 4, 5, 7, 8. 2, 2, 5, 7, 4, 2, 5, 7, 2. Okay, so what will be the LCM of this? So LCM will be 5 into 2 into 2 into 5 into 7 into 2. 5 into 2 into 2 into 5 into 7 into 2. So this will be 100, okay, and this will be 40. So required LCM will be 40, 100. Okay. Now we will subtract the given number with its corresponding remainder. Since we will subtract 20 with its corresponding remainder, that is 40. Similarly for other number, hence n1 equals to 20 minus 40, which is equal to 6. Similarly, n2 equals to 25 minus 19, which is equal to 6. Similarly for 35, n3, 35 minus its corresponding remainder, 21. Okay, sorry because the question was wrong. For this number 35, its corresponding remainder was 29, not 21. Initially, I had written 21, but it was wrong. 29 is the right one. So we will subtract the number 35 with its corresponding remainder, which is 29. The result will be 6. Similarly for N4, 40 minus 34, which is again 6. Now after subtracting, we can see that all numbers are common, which is 6. Okay. So to get the final answer, whatever be the LCM, from LCM subtract this common element. Means LCM is 1400. So 1400 minus the common one, which is 6. Okay. So the final answer is 1394. So this is the required answer. So we can say that 1394 is the least number which on dividing these four number leaves remainder this four. That is 1491, sorry 19, 29 and 34 respectively. Okay, now we will see next type of question. Question says find the greatest number of 5 digits which is divisible by 15, 21 and 36. So in this type of question, see whenever in this type of question, whether the question asks for greatest number of any digit or smallest number of any digit, always find LCM. Okay, so first, what will be the greatest 5 digit number? Greatest 5 digits number 99999. Okay, the greatest 5 digit number. Now we will find LCM of 15, 15, 21 and 36. Okay. 5, 7, 2. So the LCM will be 3 into 5 into 7 into 12. Okay. Which is equals to 1260. This is the required LCM 1260. Okay. When you multiply this number, you will get 1260. Now, as question says that what will be the greatest 5 digit number which is divisible by this. So, when we divide this greatest 5 digit number by 1260, what will be the remainder? Okay, 1260. When we divide greatest 5 digit number, what will be the remainder? So remainder will be 459. Okay. Now, so what will be the required greatest 5 digit number? Simply, whatever the remainder is, just subtract this remainder from the greatest 5 digit number. Means To get required number, what we have to do, what we need to do, just subtract greatest 5-digit number, which is 99999 minus 459. What will be the result? 0, 4, 5, 9. So this will be your required number answer, which is divisible by 15, 21 and 36 respectively. Okay, now we will see another type of question. The question says find the smallest number of 5 digits which is divisible by 16, 24, 36 and 54. So same process as I already said that whenever in this type of question, whether the question asks for greatest number or smallest any digit number, we always need to find LCM of the given number. But before finding LCM, what will be the smallest 5-digit number? So smallest 5-digit number will be 1. Okay, 10,000. Now we will find the LCM. Okay, whether the question asks for smallest of any digit number or greater number of any digit, always try to find LCM of given number. So what will be the LCM of 16, 24, 36 and 54? 6, 9, 27 will remain as it is. 2, 6, sorry, 3, 9, 27. 1, 3, 9, 2, 1, 1, 3. What will be the LCM? LCM will be 2 into 2, 4, 8, 24 into 3 2s are 6, 3s are 18. Okay. So what will be the result? 432. So the LCM of 16, 24, 36 and 54 will be 432. Okay. Now, from here the process will change. As we have seen in the previous question, what we did that first we found the greatest 5-digit number, then we found the LCM, then we divide and simply whatever the remainder we got, simply we subtracted that remainder from the greatest 5-digit. But from here we will divide. Okay, we will do division. Means we will divide 432 10,000. So when 10,000 will be divided by 432, what will be the remainder? So remainder will be 64. Okay. Till here the process is same as compared to the previous question, but from here the process will get changed. Okay. So in this type of question, we will find the difference of divisor and remainder. Okay, that is 432 minus 64. 8, 6, 368. Okay. Now we will do addition. Means we will add 368 from 10,000, which is smallest 5-digit number. So our required number will be 10,000 plus 368, which is equals to 10,368. So from here the process is different as compared to the previous question, but till here the process remains same as compared to the previous question. So this is your required answer.
But how does your mother do?
Okay, now moving to the next question. So this is the final question I am doing from this chapter. This question generally comes in campus drive. The question says find the number of zeros in 500 factorial. Uh, to solve this kind of question, simplest way is how we can write 500 factorial. So we can write 500 factorial as 1 into 2 into 3 into 4 into dot 500. Okay, so it is not possible to find HCF of each number or LCM of each number and then find 0. So the simplest way is divide the number by 5. 500 divided by 5. So we will get 100. This 100 is nothing but quotient. So this is quotient. Okay. Then again divide by 5, we will get 20. This is also quotient. Okay. Then again divide by 5, we will get 4 as quotient. So we will divide 500 by 5, whatever the quotient we get, again divide by 5, same process. But here we cannot divide by 5 because 4, what the quotient which we are getting here is less than the 5. So whenever we get quotient less than 5, we will stop there. Okay, since 4 is less than 5, so division not possible. So what will be the number of zeros? Number of zeros will be simply q1 plus q2 plus q3, which is 100 plus 20 plus 4, 124. By this process, uh, we can solve any question, any this type of question, whether in place of 500, if the question asks for 10,000 or 10 lakh factorial or anything, any number, just follow this process and you will get the result. So friends, this is all about HCF and LCM. I hope you like it. So please subscribe our channel Beginnertopro and like our video, share, and for any queries please comment. And again I am telling you that practice as much as possible. So for better practice, go to our site beginnertopro.in/aptitude. Okay, here you will get variety of question. You will also get topic wise test. So you can be pro when you enter this website. You can practice a lot and you can get command on each and every topic. So thank you.